very much. Let's have a look at this question. That's mechanics question. It said the angle between two forces. The angle between two forces, P and Q, acting at a point is 40 degrees. These forces are acting at a point. If the magnitude of P and Q are 12 newtons and 8 newtons respectively, calculate, correct to 1 decimal place. I, magnitude of the resultant force. I, the angle which the resultant force makes with the P, that is the force P. So let's look at how to solve this question. One important thing is that if you have a question like this, how do you start it? Mechanics is very important. How do you start it? Because they are starting from a particular point, then the forces must be represented on the side of a parallelogram, especially when they are initiated from one point. You see, like this. This force starts from another point, and they start from one point. Let's say this is a particular point, and this force starts here, and then they are initiated from a particular point. They start from a particular point. In that case, the forces must be represented on the side of a parallelogram, especially when they start from a particular point. Apart from that, when the forces are given, the magnitude of the forces are given, and different forces, and you are asked to find the magnitude, because the diagonal can serve as the magnitude of the force. But that one you can use triangle of forces to solve it. But particularly when they start from a particular point, like this one, magnitude of force P and Q are 12 newtons and 8 newtons respectively. The angle between two forces P and Q acting at a point. So a force acting at a point, that is giving you a clue, that alone, that the magnitude of the force must be represented on the side of parallelogram. So let's start. Parallelogram. If you have a parallelogram, what is a parallelogram? Parallelogram is a quadrilateral with parallel sides, and then with a pair of sides being parallel, with a pair of sides being parallel. You see, this pair is parallel, this pair is parallel. So if there is a force, let's say this force F1, force F2, and they are acting at a point, this point, the angle between this point is theta here. So if you have theta here, you know the parallelogram, let me extend it small here. If I theta here, it means the angle outside here will be 180 degrees minus theta. You see that? And if you extend this line small, you see this line is parallel to this, so this angle to this and that are alternate angle. Here will be 180 degrees minus theta. So if here is theta, now and parallelogram, if here is theta, it means here is also theta. If here is theta, then here also be theta. Here will be 180 degrees minus theta. And this is the diagonal. The resultant force R. The resultant force is R, because this force is moving this direction, and this force will close it. So this is the resultant force. So it means that the angle that has been given here is 40 degrees. So how do you get this angle with 180 minus what? 40. You see that? So you should understand why we have here 180 minus theta. It's very important. You should, as a mathematics teacher, the student should not be told that here is 180 minus theta. Why is it 180 minus theta? Because it can be gotten here, then it alternates here, and opposite angles of a parallelogram are the same. So if here is 180 minus theta, here is 180 minus theta. Now, if here, so in that case, our theta here, if here is P, what is Q and P? P and Q are 12 newtons, so this is 12 newton, and then Q is what? P and Q. Q is 8 newton. You see that? This side is also equal to this side. This side is also equal to this side. So if this side is parallel to this, so here is also 12 newton. And the top here is also 8 newton. You can pick any of the triangles. You can pick this triangle. Let me name here A, B, C, D. This is how to name parallelogram. Parallelogram go this way: A, B, C, D. Do you see that? It doesn't go A, B, C, D. No, A, B, C, D. That's how we name parallelogram. Now we can pick triangle BDC. So from triangle BDC. Now we know this side, we know this side. We want to find the resultant force, so we can use cosine rule. So we have r squared is equal to, this is P and this is Q, so P squared plus Q squared minus 2PQ cos the angle between them. The angle between them is angle between Q and P is this 180 minus theta. But cos 180 minus theta is the same as negative cos theta. But let's leave it here. So r squared, the resultant force squared, is equal to, what is P? P is 12 squared plus 8 squared minus 2 times 12 times 8 cos 180 minus theta. 180 minus theta is what? 40 degrees. So theta here, the whole of this angle is 40 degrees. Which is theta? 40 degrees. So theta here is 40 degrees. Now cos 40, 180 minus 40 will give us 140 degrees. Now r squared is equal to 144 plus 64. 12 times 8 times 2 will give us what?
192.
Minus 192 cos 140. Now, let me continue from this side. R squared is equal to 144 plus 192. What do you get? This plus that, what do you get?
208.
208 minus, in fact, press 192 cos 140. I see here to give me plus 192. 192 cos 140, what do you get?
Negative 14.
So negative here will give you negative, and there's another negative here, so it will give you plus what?
Negative 14.
147.8
08.
Is it 08?
Yes, sir.
08.
05.
It's okay. So r squared is equal to, add these two, what do you get?
Zero, 355.
355.08.
0.08. Yes.
Then square root of that. Take square because r squared. Take square root of the answer.
Okay.
R is equal to square root of 355.08. R will be equal, that's the magnitude of the resultant force. Will be equal to what?
18.8.
18.8 Newton. In fact, I said that to one decimal place. So it's 18.8 Newton. The resultant force is 18.8 Newton. And that gives you the answer. Now, let's go to the next question. It says the angle which the resultant force makes with the P. What is the resultant force? This is the resultant force. Mixed with the P. What is the P? So this small angle here. So that would be this angle here. With the P. So that angle, let me name that angle alpha. So I will clean this part because it is already known. The question is known. So what happens is that, let me take that part. This is the resultant force R, and this P. which is equal to 12 Newton. And here is 8 Newton. And in fact, the angle is this. This angle, let me name this angle alpha. And here is 140 degrees. Because this part is equal to this part. And the angle, the whole of that angle is 40 degrees. So 1 minus 40 will give you 140 degrees. So here is 140 degrees. And we are asked to find the angle alpha. This angle, the angle is the resultant force. The angle of the resultant arrow mixed with P. This is a P. So, what do? We can use sine rule. Arrow over sine 140. Arrow over sine 140 degrees is equal to 8 over sine alpha. 8 over sine alpha. And the arrow is 18.8 Newton. So 18.8 over sine 140 degrees is equal to 8 over sine alpha. Now, let's continue here. We cross multiply. So we get 18.8 sine alpha is equal to 8 times sine 140. 8 sine 140 degrees. So that you divide both sides by 18.8. 18.8. This one cancels this. We have sine alpha is equal to 8 sine 140 divided by 18.8. Now press 8 sine 140.
5.142.
Then the answer divided by 18.8. So sine alpha is equal to
0.273.
0.273.
Yes, sir.
Now we want sine inverse, or you can take sine from both sides. Sine of sine alpha will give you alpha, or take sine inverse. So alpha is equal to sine inverse of 0.273. Alpha is equal to
15.842.
15.842. So it's 15.8
Okay.
degrees. Because it is an angle, so it should be in degrees. But because we said 1 decimal place, so it should be 15.8 degrees. And that is the angle that is between the resultant force R and the magnitude of the force P. Thank you very much for watching me. I am Hussein Abdurazak. You can like, share, or watch me at YouTube, Ninja Easy Mathematics, and may God bless you.